afternoon. Today we are going to discuss on VIP question, chapter 6, alternating current. Okay, so let's start with the first questions. A pure inductive circuit current where the current here is actually lags behind EMF by pi over 2. Okay, because we know that when current start from 0 degree, our VL is already leads I by 90 degree. Okay, so meaning that the current lags meaning that belakang. Okay, I is lags our VL by 90 degree or pi over 2. Okay, questions number 2. The impedance value of the pure resistor. Okay, so the impedance actually is equal to Z. Okay, so if let's say it's RCL series, impedance equation is equal to R square plus XL minus XC square. Okay, so since this is only a pure resistor, okay, meaning that we don't have R, we don't have L. Okay, so meaning impedance value of the pure resistor. Okay, so the impedance actually is equal to Z. Okay, so if let's say it's RCL series, impedance equation is equal to R square plus XL minus XC square. Okay, so since this is only a pure resistor, okay, meaning that we don't have R, we don't have L. Okay, so meaning that the impedance here only equals to XC. Okay, so the impedance of XC here is equals to 1 over omega C. The answer here is C. Okay, third questions. Calculate the phase angle theta between I and also Vx. Okay, so I and also Vx, the angle here, okay, we can use either cos theta or we can use tangent theta. Okay, so since we have VL, we have VR, we have VC, so we actually can use tangent theta to find. Okay, where tangent theta is equal to y component over x component. Okay, so for this part, y component is actually VL minus VC. Okay, so it's VL minus VC. X component we have VR. So we substitute in the value. VL is 9 volt, VC is 7.5 volt, VR is 2 volt. Okay, therefore theta is equal to 36.9 degree. So the answer here is D. Okay, next, calculate the source voltage Vx. Okay, so we notice that this is actually RCL series because we have inductor, we have resistor, and also we have capacitor. Okay, so the equation for V source is equal to VR square plus VL minus VC square. Okay, and then square root. So our VR here is 2 volt square, VL is 9 volt minus VC is 7.5 volt. Okay, therefore V source or Vs here is equal to 2.5 volt. So the answer here is A. Questions number 5. An alternating current supply is 70.7 with the frequency of 50 Hz. So 70.7 actually is our VRMS because the questions didn't mention this is a V0 or V peak or V maximum. Okay, so meaning that 70.7 here is actually VRMS. Okay, with the frequency of 50 Hz. Okay, which of the following statement is false? Okay, false. Okay, number 1, the periodic time is 20 milliseconds. Okay, so the period here is equal to 1 over F. So I substitute F is 50 Hz. Therefore, I will get 0.02 second. Okay, so 0.02 if you compare with 20 milli, so 20 milli, okay, is actually equal to 0.02 second as well. So this is actually correct. B, the peak value of the voltage is 70.7. So actually 70.7 is VRMS. Okay, so actually B is wrong. Okay, next C, the RMS value for the voltage is 70.7. So this is correct. D, the peak value of the voltage is 100. Okay, so our VRMS is equal to V0 over SLIT2. Therefore, our V0 is equal to SLIT2 times VRMS, or SLIT2 times 70.7. Okay, therefore we will get 100 volt. So this is actually correct. So the answer or the statement is false is actually B. Okay, next we go to question number 6. Find the root mean square value of the alternating current if the maximum current is 25. So I0 is actually 25 ampere. Okay, so in order to find IRMS, so IRMS is equal to I0 over SLIT2, where I0 is 25 over SLIT2. Okay, so if you press calculator, we will get the answer is 17.7 ampere. Answer is C. Next question number 7. Okay, using the alternating voltmeter, the potential difference in the electrical line in the house is read by 234 volt. Okay, so 234 volt here is actually VRMS. Okay, because the question does not mention whether it's maximum amplitude or the peak value. So meaning that usually the value that given is VRMS. Okay, if the line frequency is known as 50 cycle per second, so here actually they give us the information of omega, where it's equal to 50 cycles, so 50 times 2 pi within 1 second. The equations of the line voltage is, okay, so we want to construct an equation for the voltage where V is equal to V0 sine omega t. Okay, so now we want to find V0 because VRMS is equal to V0 over SLIT2, where V0 is equal to SLIT2. Okay, therefore V0 is equal to SLIT2 times VRMS. Okay, so SLIT2 VRMS is 234 volt. Okay, therefore V0 we will get 330.9. Okay, so I substitute in V0 is 330.9 volt sine omega t. Okay, so omega here is actually equals to 100 pi. Okay, so it's sine 100 pi t. Okay, so this is the equation. Therefore, the answer is B. Okay, next we go to question number 8. A coil of the self-inductance 1 Henry has been connected to an alternating current with the frequency of 10 Hz. Determine the inductive reactance. Okay, so the inductive reactance XL is equal to omega L or 2 pi FL. Okay, so we can substitute in 2 pi, F is 10 Hz, L is 1 Henry. Okay, therefore it's equal to 20 pi or is equal to 62.84 ohm. The answer here is A. Okay, question number 9. Determine the value of inductive reactance XL in capacitive reactance XC circuit of the impedance. Okay, so we need to find what is the value for XL, XC, and also impedance Z. Okay, so here they give you the value for the resistor, inductor, and also capacitor. So the first one, okay, we can use XL equals to 2 pi FL, where the frequency here is given 50 Hz. So I can substitute in 2 pi, frequency is 50, inductor is 0.15. Okay, therefore we will get XL equals to 47.13 ohm. Okay, next XC. Okay, XC is equal to 1 over omega C or 1 over 2 pi FC. Okay, so I substitute in 2 pi F is 50, C is the capacitor, 100 microfarad. Okay, therefore, if you press calculator, the answer that we will get for the capacitive reactance is 31.83 ohm. Okay, and then go to the last part. Impedance is equal to square root R square plus XL minus XC square, where R here is 12 square, XL is 47, and XC here is 31.83 ohm. Okay, therefore the impedance that we will get here is actually equals to 19.4 ohm. Okay, so answer here is XL is 47, XC is 31.83, and then Z is 19.4. So the answer here is A. Okay, next we'll go to questions number 10. What happened to the resistor if frequency double up in alternating circuit? Okay, so as we know that resistor does not affected by F. Okay, therefore, if the frequency double up, the resistor still remain unchanged. So the answer here is D. Okay, next questions 11. An alternating circuit has a resistance of 12 ohm and the impedance of 15 ohm. Okay, find the power factor. Okay, so as we know that this is the resistor and this is the impedance, and the angle here is theta. Okay, so if you want to find the power factor, meaning that we want to find cos theta. Okay, so cos theta here is actually equals to adjacent over hypotenuse, where R over Z. Okay, R is 12 ohm, impedance here is 15 ohm. Okay, therefore the power factor cos theta is equals to 0.8. So answer is 8. Okay, next we go to questions number 12. In an LCR circuit, capacitance is changed from C to C. For the resonance frequency to remain unchanged, the inductance should be changed from L to, okay, so meaning that resonance frequency equations, okay, resonance frequency is equals to 1 over 2 pi SLIT LC. Okay, so in order to remain the resonance frequency, meaning that resonance frequency for before and resonance frequency after that is equal. Okay, so we can substitute in 1 over 2 pi LC equals to 1 over 2 pi L2, and now C become 2C. Okay, so we want to find what is the new value for L2. Okay, so we can cancel off 2 pi and 2 pi. Okay, therefore LC is equals to 2C L2. Okay, so since C is equal, so we can cancel off. Therefore L2 is equals to L over 2. Okay, so meaning that the inductance should be changed from L to L over 2. So the answer here is C. Okay, next questions is questions number 13. As XL is equals to XC in the resonance, okay, the impedance here is equals to, okay, so from the equations here, impedance is equals to R square plus XL minus XC square. Okay, so when resonance happen, XL is equals to XC. Okay, so when XL equals to XC, this one becomes 0. Okay, therefore impedance now is equals to SLIT R square or equals to R. Okay, so the answer here is the impedance here is equals to purely resistive. Okay, so the answer here is C. Okay, next we go to questions number 14. In series of RLC, XL is 10 ohm, XC is 4 ohm, R is 6 ohm. Find the power factor of the circuit. Okay, so here we have XL is 100 ohm. We have XC is equals to 4 ohm, and also we have R is equals to 6 ohm. Okay, so in order to find power factor, okay, power factor meaning that we want to find cos theta. Okay, so cos theta here is actually the angle between our impedance and also R. So we can use the equation cos theta equals to R over impedance, where R is equals to 6 ohm. Okay, so if you want to find impedance, we can use the equation Z equals to R square plus XL minus XC square, then square root. Okay, where R is 6 square plus XL is 10 minus 4. Okay, so it will equal to 6 square plus 6 square. Okay, so it's 36 plus 36, or is equal to square root 72. So we substitute inside here 72. Okay, so if let's say we want to find cos theta, okay, if you press the calculator, we will find out that actually we will get, okay, we will get 0.707. Okay, so the answer is A. Okay, if let's say you don't want to change, okay, this one 6 here, we also can convert it into 36 square root over 72. Okay, so we can cancel off 36 over 72. We can write it like this. Okay, we can write it as 36 over 72. Therefore, it's equal to square root 1 over 2. Okay, or we can write it as 1 over 2. Okay, so the answer here is A. Okay, so it's if you press the calculator, 1 over 2 is actually equal to 0.707. Okay, next we'll go to the last questions. Questions number 15. In a series resonance, the series resonance occur when, okay, so the resonance occur when, okay, choose which apply can be more than one answer. Okay, so resonance happen is when our V source is in phase with the current. Okay, so when V source is in phase with the current, meaning that our V source is actually equal to VR and VL is equal to VC. Okay, or we can write V source here is actually impedance, is equal to R when XL equals to XC. Okay, so number 1, Vs in phase with the current, so this one is correct. Okay, this one is correct. Number 2, Z is equal to R. Okay, Z is equal to R because XL equals to XC. Okay, so number 1 and number B and C is correct. And then we also can write VL actually equals to VC. Okay, so actually all are the answer. Okay, so that's all for this video. We will continue with the next subtopic, VIP 7. Okay, see you on next video. Bye.